Hello guys, welcome back. Today we are going to see the first problem of Hello 2022 contest, which was the first contest of this year. So yeah, I hope you are doing well. I'm so sorry for not uploading any videos from a long time because I have some exams going on my college. But now on, I will be consistent. So let's start the problem. So you have n into n chessboard and you have given k rooks. Okay. Rows of this chessboard numbered from 1 to n. Yeah, okay. Columns, it's also from 1 to n. The cell xy, in the cell xy, x is uh, x row and y is yth row. Okay, the arrangement of rooks on this board is called good if no rook is beaten by another rook. Yeah, if a rook can, if all rooks cannot don't beat another rook, then the arrangement is good. Yeah, fine. A rook beats all the rooks that shares the same row or column with it. Okay, if a rook is in same row or same column of another rook, then it is beaten. Yeah, right. Okay, the good arrangement of rooks on this board is called not stable. Okay, if it is possible to move one rook to adjacent cell, so arrangement becomes not good. Yeah. Okay, otherwise the good arrangement is stable. Here, adjacent cells are the cells that shares a side. Okay, let's understand what is the question telling us. Let's say we have 4 into 4 chessboard. You can fast forward this video if you think it's slow. So if I place one rook here, what the question means by good arrangement is that if I place one rook here, okay, and if I place one rook here, then it is not valid because if another rook is sharing same row or same column, then this condition is not good. Okay, so I cannot place another rook on the same row or same column. So you can say just place the rook here, like in the second row, which is not in the same row or not in the same column. So I'll say yeah, okay, just place it. But the question is also saying that this good arrangement can be not stable if it is possible to move one rook to adjacent cell. So what is meant by adjacent cell is we can go to upper row or we can go to lower row or we can go to left column or we can go to right column. So if I move to left column, then again I am in the same column, or if I go to upper row, then I am in the same row. And so that's why we cannot put a rook here. So if I put here, uh, just remove it. But if I put here and the rook, then if I'll go right, if I go to the right column, then it's fine. If I go to the left column, then it's also fine. If I'll go to the third row, then it is also fine. But I can also go like this is also adjacent row, so I can also go to first row. So this condition is also not possible. Okay, so it is not valid. So I cannot place rook here, and from that you can also see that I can also not place rook here. So from this, what you can understand is if I place one rook here, like then I cannot place another rook in the same column or the same row or in the next row, because if I place in the next row, then it can move to the same row by one move. Okay, so I have to make the distance between another rook is of one row or one column minimum. Okay, so so where I can put another rook? Yeah, I cannot put another rook here because from one move I can go to the same column. So this will be not good. So for this, where should I put it? If I put here, that is fine. Let's see if I can move here. then it is fine. If here, then it is fine. If here, then it is fine. And if here, then it's also fine. So yeah, okay. So just place another rook here. So we are good. So what you can see that we can only put two rooks. Well, let's see. We can put a third rook anywhere. So we cannot put here. So this is not valid position. And we see from previous cannot put rook here. Okay. So yeah, this is also not valid. And if we put another the second rook here, then this place is also not valid. And if I put here, then I can easily go to the same row or go to the same column. Then this place is also not valid. So we can only put two rooks here. If it is a 3 into 3 chessboard, if I put one rook here, then I cannot put here and I can not also put here. So what is the position left? This or this. So you can put here or there, it's your choice. So what you can see here, you can only put maximum number of rooks is n by 2. So if n is odd, it doesn't matter. Oh, it matters. 3 plus 1 divided by 2. So 2. If n is even, so it is only n by 2. So it is 2. So now we understand the problem. Okay. So we have what is the output format? If there is a stable arrangement of k rooks n into n chessboard, output n lines. Okay. With symbols dot and r. R means rooks and dot means it's an empty space. Okay. And if a stable arrangement is not possible, then just print -1. So let's write the code for it. N and K, C and K. And just so you know, I have taken care of the test cases. Here I am entering the test case and I am doing this for every single test case. Okay. So here what we can check is if the number of rooks is greater than the maximum number of rooks we can handle. So what is the condition for it? If k is greater than uh, how we can write is as like that. If k is greater than n plus 1 divided by 2, then simply print -1 and return from this, or else there is an answer. Okay, I will traverse in every row, or not in every row. Just say I said that, like, if I am putting one rook in first row, then I will put another rook in the third row. Then if the chessboard is side, then I will put another rook in fifth row. Okay. So and another loop is from I, or you can just write it as just make this j is less than n and j plus plus. It's better to if you can store this, and after making all the changes in the end just okay. This is factor of string. So is factor of string, or just remove it, just print direct answer. So we cannot waste any extra memory. Okay, or first I have to tell you where I am putting groups, my code. It is a 4 into 4 chessboard. I am putting at 1 1 position. Okay, I am leaving 2 2 position. Then I am putting at 3 3 position. Then I am leaving 4 4. And if the size is maximum, then I am putting at 5 5. So I am putting at every odd positions, right? But in this case, it is starting from 0. So I am putting at every even position. Okay. So if I equal to j and I is even. So what is this condition? This is the diagonal. This is the diagonal. And if they both are equal, then this means it is diagonal. And where I am putting, I am only putting at odd positions. Why first position? Because in case of odd number of chessboards, like in the case of 3, if you start from this, then you can only place only one rook. You cannot place more than one. So that's starting from this position. So if I equal to j and I modulus 2 equals to 0, which means this position is even. And one more condition, if k is greater than 0, because if the number of rooks, if the given number of rooks is 0, then we don't need to place any rooks. We just leave the space empty. Okay. So in that case, print one rook. Okay, and just decrease k with 1. If it is not the case, then just leave the space empty and go to the next line. So this is my test case. Running it. Yeah, it is slow. So yeah, for the first case, it is chessboard size is 3 into 3 and number of rooks is 2.